Hi everyone, welcome to the last episode of this week. This is Learning Kotlin Live, and we will be talking about the. Wait a moment. Yeah, we will be talking about the Lambdas and maybe higher order functions of Kotlin today. So Kotlin functions are first class. I don't know what this means. Is this a wiki page? Yeah. Which means that they can be stored in variables and data structures. So it means there are function pointers, I guess. Passes arguments to and return from other higher order functions. That's definitely another. Oh, that's not it. We will be talking about this later. Actually, it's immediately. So you can operate with functions in any way that is possible for other non-function values. Function types. It's still in this page, so we're not going to talk about it. To represent functions and provide a set of special language constructions such as lambda, it's still here. So a higher order function is a function that takes function as parameters or returns a function. It's somewhere at parameter, or it's either in or out. A good example is the functional programming idiom fold. Okay. For collections, which takes an initial accumulator value and a combining function and builds its return value by consecutively combining current accumulator value with each collection element, replacing the accumulator. Okay. So collection. This is an extension function of collection, and its name is fold of type T, and the initial. I wonder what initial is. There's an initial R. Oh, it looks like adding. I'm doing an operation with R and collection of T. So there's an initial R, and it also it returns an R, and it needs you need to pass in the initial value of R, and you need a combining function which takes the R with the name accumulator and takes an element of T and returns a R. So okay. So in the function body, what it does is first take the initial and save it into a variable accumulator, which is of type R, and then for each element T of type T, element of type T in this. Why do we need this? Why do we need this T? Oh, because this is a function body of a, okay, element of type T in this. I wonder if we can just skip this declaration, because this can be inferred, but maybe the compiler are just not smart enough as I am. So there are T values in this collection of T, and we are iterating through it, through this in keyword, and we name it. We name the next element and we do combine. We run a combine function with the accumulator, which is initialized and updated, and with the next element, and obtain the next accumulator, and we later return this accumulator. So this is a higher order function because there is a combine function passed in, which is in a style, which seems to be of the syntax of a lambda. I'm not 100% sure, but it looks like so. So in the code above, the parameter combine blah 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 blah. Yeah, this is just what I have explained. To call fold, we need to pass in instance of the function type. So we can call items.fold with initial value, initial accumulator 0, and there's a mapping combine function, which is what is this? Okay. Oh, that's a lambda. So with parameters ACC of type integer and I with type integer, because which means the T and R are both integer for this case. That combined function. Oh, actually, the T is already decided by the type of these items, which is a list of integers, and by this with this accumulator 0 here, we have also defined R, so we know that ACC and I are both integers. And what we do is print it out, and then result is the combine function combines or adds ACC and I. So that would be items.fold would return 15. That's it. Where does this product come from? Oh, and there is another product functions. And what is this colon syntax here? Oh, okay, times. Function reference. So times is, where is times defined? No, it's not defined, really. Let's take a look at this int in Kotlin. Times, and that's oh, that's an operator. Oh, okay. So there is either a shift. There are both infix functions and operator functions, which I don't know what's the differences yet. But I always saw that infix functions are they are a replacement of operator functions. Kotlin infix. Here it is. Operator overloading. So where is the operator keyword? Oh, okay. Functions that overload operators need to be marked with the operator modifier. So times here is items.fold. Item is 1, 2, 3, 4, 5, and it starts with 1. So it later becomes 1, 2, 6, 24, and 120. And this is an operate. And this is a function which is referenced by the class name. And let's see. Times is an operator function which returns okay, so I don't know how we manage to, because it does not state it's public. So I wonder how we managed to call this. Okay, maybe we should see it someday, but now all we need to remember now is we can call it just like Java. Okay, I hate to know only partial stuff, so let's see. Double colon Kotlin. So I still don't get what a double colon syntax actually means. Oh. Creates a member reference or a class reference, and that's what I'm looking for. So function and class reference. Oh, so it will be reintroduced in reflection, and someday we will know it, but I think all we need to know now is we can reference the class by double colon class, and we can reference a function with double colon as well. Reference to functions, properties, and constructors apart from introspecting the code using a common supertype, blah blah blah. We're not going to cover this today because we need to cover it in the future. So, alright then, let's take a look at here. Function types. I think the double colon syntax probably will be covered here as well. No? Oh yeah, it's actually covered. So maybe not now. Kotlin uses a family of function types like what? What is this? Did I miss anything? No. Oh, this is kind of just talking about the what I believe to be Lambda syntax, but maybe actually not. I don't get this, what this sentence is for, but let's continue reading it. Yeah, these are function types and they correspond to the signature of the functions. So all function types have a parenthesized parameter type list and a return type, so that is A, B means it takes two arguments of type A and B and return a type Z. So we can leave the AB blank, empty if there is no return. There is no parameters, but if there is no return type, we need to make unit explicitly, which kinda are just syntax. No, the opposite of syntax jokers. It's actually just hint for compilers that can differentiate different syntax easier. So function types can optionally have an additional receiver type, which is specified before a dot in the notation. Ooh. Don't get it. So we will talk about this later. Represents that functions that can be called on a receiver object of A. I don't really get this one. Suspending functions belong to function types of a special kind, which have a suspend modifier in the notation, such as suspend blah blah unit or suspend a dot blah blah letter. The function type notation can optionally include names of the function parameters. Yeah, you can give them names if you want to, but you can just have int. Their names can be but point is a return type. Can be used for documenting the meaning. Yeah. The function type is newable. Wait. So this is a newable function type. Can be combined with parentheses. Huh? What is this? That returns a function. Okay. So the arrow notation is right associative. So this means just please guys, just do the parenthesizing. Don't leave it this way. So that, but anyway, it's going to be equal to this one. Right, have the precedence. Function type and alternate name by using a type alias. So that's where this click handler comes from. Click handler. Well, it is not used here, but that means that we can just skip this. So it means that in the future, if we want to wherever we need this predicate, predicate of t means a t and returns, it takes a t and returns a boolean. So we can, instead of writing this t returns a boolean here, we can simply use a predicate t here, predicate of integer here. So I kind of feel like I'm running out of time. Okay, we might need to split this into two parts. So instantiating a function type, we can either use a lambda expression. So this is a function type, which just comes inside the declaration of a function, higher order function or whatever. Yeah, higher order function. This is optional. Is it? I think so. I know this is not optional. So there's a function of type blah blah, and its name is combine, and this part here is the function types. Oh, it's called function types because it's the type that points to a function. Okay, yeah, I called it lambda, so it's actually incorrect. We should call it a function type. Is it? Yeah, a function type. And a lambda is an instantiation of a function type. Where are you? Here. So this is a lambda with brackets. I don't know. Big brackets? What's the name of it? Curved brackets or whatever. So it takes a function AB. It takes two parameters A and B, and it adds slam. So we can also have an anonymous function. I never heard of that term. Anonymous function. Yeah, it's described later too as well. We can have anonymous function, which seems to have the format function, and that seems to be just a longer version of a lambda, or at least something that we can write a lot of lines in it. Function literal with receiver can be used as value of function types with receiver. What on earth are you talking about? Functions literals with explicit. Nah, it's going to be talked about somewhere, not now. So that's a code block style, but we can also call a reference an existing function. So it can be a top level local member or extension function. Just use double colon. Property? Why can't it reference a property as a function pointer, as an instantiation of a function type? This does not make any sense. A property can actually point to function, but okay, so we can use property if that property's type is exactly the return type of what we want, and if it takes no argument. Property always take no argument. So if the function type of our function takes no argument, it's just empty, like here it is. A top level member or extension. So it can be a local property. Is there any local property? Local property? I think so. Yeah, there is a local property, but maybe we just don't need to reference it. I'm not pretty sure about that. A constructor. Okay. That's actually a little bit weird. Bound callable reference that point to a member of a particular instance. What is a bound callable? Okay, that's something we're going to talk about in reflection as well, but it's bound to its receiver. Oh my god, I'm not going to read it now. That is just too hard for me now. Using instances of a custom class that implements a function type as an interface. There's a class that implements a function type. So what's the difference between? What's the difference between anonymous function in this class. Oh, it's named. But why don't we just write a function for it? Using instances of a custom class that implements a function type as an interface. Huh. Okay. And there's going to be a function invoke that takes int and returns int. So we can instantiate this. What? Wait. What? We point the function type to int transformer, which, okay. And what's this to do here? Come on. Oh my god. But yeah. We need to write more with this syntax to understand it more thoroughly. So the compiler can infer its function types of variables if there is enough information. And this is inferred because we know this is a lambda function. Is it? Yeah, this is a lambda function which takes in I of type integer and returns the I plus 1. Non-literal values of function types with and without receiver are interchangeable. There is a repeat function. It is an extension function to the string, and it takes an integer and it returns a function which, nope, it's actually, wait, that's a extension function of string, and where's the function name? Oh, okay, so this is actually, it can be passed, or this is actually not extension function, or at least not what is called here. This is wait a minute, this is a receiver, a function literals with the receiver. Come on, you never talk about this. Let's first look at this function. Run transformation. It takes a lambda. It takes a function type of string, integer, parameters, and returns a string, and that is and this run transformation would run. It would involve this pass-in f, and run it with hello and 3. So it's going to run this transformation f, and so repeat function. Anyway, it's going to run this transformation with parameter hello and 3. So with run transformation, we define the parameters to be used in f, and the f we're going to use is repeat function, which is of type So I kind of feel like this is actually very alike to the extensions, but it's just called receiver type here, and the receiver is going to be used. It's going to be used like how we use the extension functions. It's going to be referenced by this. So we call that repeat function, which can be used just like a string.int parameter can also be used as can be used at integer.string. Two parameters, string and integer, but it is just more explicit that we call we're going to reference the string parameter with this. So in this function, the string is this, and this will be repeated. Let me take a look at if there's such Kotlin. If there is such repeat function here. Nope. So where is that repeat used? Two parameters. We pointed to repeat func because this is what it's talking about. It can be passed assigned with blah blah, and the other way around. Alright, this repeat is not defined here. Let's take a look at. It's implementing char sequence, so maybe there's a repeat here. Nope. Come on, this is so. I don't think it's going to be comparable. Yeah. So where's that repeat? Maybe in 1.3. Nope. Still not there in 1.3. Where does that repeat comes from? I'm going to assume that I'm going to assume its existence. Yeah, I don't care about it now. So anyway, so that's a function that returns 3 times the string. The string that is passed in. It's actually repeat n times, and it takes a time. So yeah, that's the syntax. Invoking a function type instance. We're going to stop here. So this is the last part. Invoking a function type instance. A value of a function type can be invoked by using its invoke operator. Okay. So f is a function. F is a value. F is a property. Property. Kind of. F is a property of type. Of a type class type, and we can just call f.invoke, or which also means f parenthesis x. If the value has a receiver type, the receiver of type, yeah, this is what we've seen. We need to go one.foo or this.repeat here. Like no, it's actually hello. No. So the repeat function is not called it directly, right? Well, yeah, we can call either hello dot f. Actually no, because it's defined this way here. Maybe not. Maybe yes, maybe not. But I tend to say no, because it shouldn't be interchangeable. Although it claimed that the other way around would be legal. Okay. So yeah, it's actually legal here, run transforming. I think it should be legal only as long as the two parameters don't collide. Or we'll probably need to, I don't know, name it, or I mean give them names to make it more readable, probably. So this is just telling us that when we want to invoke, there is 1, 2, and this is 3. So this is using the second way. So yeah, this is just, we can either call int plus is int. Oh, actually this is 2 ints, and it's directly referencing the plus. Why do you bother write another one then? So int plus dot invoke 1 1 or int plus 1 2, or even though actually no, yeah, only when the pointer is of type with receiver type. So if this is not, can we change it? If it is of type, we probably can call it as 1. Huh? Let's mark this one. Oh yeah, so yeah, it can be referenced now because the type is incorrect now. Yeah, so that's it. Inline functions. No, we're not going to cover inline functions today. That's something we will cover in the future. Here. So that's all for today. And that's the first part of higher order functions and function types. And we're going to talk about Lambda next time. So again, I'm going to be back. I won't be back until February 11th. So have a nice Lunar New Year, and enjoy your, if you're going to enjoy one, enjoy it. So don't bother checking my stream during your holiday. And that's all. Bye guys.